Hey everyone. In this video we're going to look at FRQ numbers 1 and 2, and we will look at FRQ number 3 in a separate video. So let's start with this one. We've got the probability that 0, 1, 2, 3, or 4 people will seek treatment for the flu during any given hour at the emergency room is given by this distribution over here. So it's a pretty standard distribution, and this problem actually is pretty standard. We're going to find, first of all, the mean and standard deviation of x. Now we've done this a few times in the previous videos. We've got the mean equal to 0 times 0.12 plus 1 times 0.26 plus 2 times 0.32 plus 3 times 0.24 plus 4 times 0.06, which is 1.86. We'll use our sentence frame, so if many, and we're looking at hours in an emergency room. And if they're chosen at random, the average, and we are counting the number of people seeking treatment for the flu, and that would be about 1.86. Check it for readability. If many hours at the emergency room are chosen at random, the average number of people seeking treatment for the flu would be about 1.86. Okay, that sounds pretty good. Let's get the standard deviation. I always start off with the variance. So we're going to square the deviations and multiply by the probabilities. So 0 minus 1.86 squared times 0.12. And then the variance for 1 is 1 minus 1.86 squared, or the variation, squared multiplied by 0.26. And then we're just going to continue this. And that's going to give me a variance of 1.2. And then, of course, the standard deviation is the square root of 1.2, which is 1.096. Here's our sentence frame for standard deviation. So the random variable here is the number of people seeking flu treatment. And that typically varies from the mean of 1.86 by about 1.096 people. For letter B, we have assuming that the number of people seeking treatment are independent in each hour, what is the probability that on 3 randomly selected hours there will be at least one person seeking treatment? So the first question we have to ask is, what's the probability that at least one person will be seeking treatment? So one thing you can do is you can add together the probabilities for 1, 2, 3, and 4. But the other way, and probably the smarter way to do it, is to say, well, if the probability of zero patients seeking treatment is 0.12, the probability of at least one person seeking treatment is going to be 1 minus 0.12, or 0.88. So the probability of at least one patient is 1 minus the probability of 0 patients, which is 0.88. Now, if we're assuming independence, the probability of at least one patient and at least one patient and at least one patient again, well, that's going to be equal to 0.88 multiplied by 0.88 multiplied by 0.88 again, which gives me a 68.15% probability. Now for letter C, suppose that for each patient, a nurse must spend 12 minutes writing a report for the record. Find the mean amount of time that nurses spend writing reports for the patients seeking treatment for the flu in the ER. So the time spent writing these reports is going to be 12 multiplied by the number of patients. And so for the mean time, that's going to be just the same thing as 12 multiplied by the mean number of patients, which is 12 times 1.86, or 22.32 minutes. Now moving on to free response number 2, we've got the average price in 2012 for a grande size drink at Starbucks was $3.7132 with a standard deviation of 0.8270. The average price for a venti drink was 4.1237 with a standard deviation of 0.7762. Assume these prices are normally distributed. So what is the mean and standard deviation for one grande drink and one venti drink? Now this is just the same kind of a question about combining two random variables. My random variable x is just the grande plus the venti. So the mean of x is just going to be equal to the mean of grande plus the mean of venti. So 3.7132 plus 4.1237. So $7.8369. Just like before, we can't directly calculate the standard deviation. We have to go with the variances. So the square root of the variance for G plus the variance for V, which is the square root of 0.8270 squared plus 0.7762 squared, or just 1.1342, or $1.13. And finally, for this video, we have Jenny ordering one grande drink for her and one venti drink for her invisible friend Bob. What's the probability that her order will cost more than $9? And this is another normal distribution because we're adding two distributions that are both normal. So a normal distribution plus another normal distribution is in fact a normal distribution. So we want to find the probability that x is greater than 9, and I don't feel bad about using x because I've already defined that x is g plus v. So if I have that written on my paper, I can use x. Now we're going to want to use a z-score here, so z is x minus mean over standard deviation. We're interested in $9. The mean is 7.8369. And the standard deviation is 1.1342. And that gives me a z-score of 1.025. Now we can put that into our probability statement. We want the probability that a z-score is greater than 1.025. Grab our calculator and go to the normal CDF screen. And we'll put in our values. So we want to know greater than $9, and we just need to put a large number here. I'm going to use the largest number in the calculator, which is E99. The mean is 7.8369. The standard deviation is 1.1342. We'll paste that in there and get a probability of 0.1526, and we'll write that in. Now the other probability here thing we can do, we can also look at this if we decided to keep everything in a z-score. So we'll do everything here in a z-score now, with the lower being our z-score 1.025. The upper limit here is still going to be 1E99. The mean for a normal curve is 0, and the standard deviation for a normal curve is 1. So we'll paste that, and we should get a very similar answer. Yeah, 1526. So very similar. And that's the end of this video. We've got one more free response video, and we'll hit that next. So we'll see you at that next one.